Hi, my name is Navadeep Budda from Lambert High School in Suwanee, Georgia, and my solution is Lucid, an AI-powered early warning system that detects driver drowsiness before it turns into an accident. The problem is simple and serious. Truck drivers fall asleep at the wheel, and fatigue is a major cause of deadly crashes. The warning signs, longer eye closures, head nods, yawns, all show up before someone actually dozes off. Lucid is built to catch these signals early, so drivers and fleets can take action in time.
That's why in recent weeks we've done everything in our power that we have to keep our truckers safe, fueled, fed, and on the road.
That quote from our presidents explains exactly why I built Lucid. Truck driver safety is a real priority at the national level, because truckers keep our economy moving. Lucid uses a phone camera, hands-free, to watch the driver's face. Every 15 seconds, it analyzes a short window and measures perclose, blink patterns, yawns, and head pose. Then it outputs a driver state: lucid, drowsy, or asleep. If risk crosses a threshold, Lucid triggers an audio and visual alert immediately. And this is a mounting system I 3D printed, because the first question is always, where does the camera go? This places the phone in a realistic, stable position with a clear view. Now let me show you the live demo. Now on this page we can see a summary of all the information about a specific driver's vitals. At the top we can see the route that the trucker is driving on and the driver's vitals to see a summary of all the information that could lead to their drowsiness. Over here we can see their live drowsiness along with their live driver feed, and we can see how their actions in the live driver feed match up to the biometrics. For example, over here we could see the percentage of eye closure and how much that has increased over time. We could do the same with head pose, yawning, heart rate, and heart rate variability. At the bottom, we could see an alert history with all the alerts and the specific timestamps of when each event occurred. Now we can see that they have been alerted as drowsy 3 times in a row, which the flight manager can use to kind of take action before. And we will soon see that they will be marked as sleeping, because over here we can see that they are asleep. Right there. In the mission control, we can see a summary of all the fleet information, and in the driver studio, we can see the individual information of all the different drivers. Here's what's under the hood. I use MediaPipe to track facial landmarks and head pose. Then I compute the fatigue signals from that and turn that into a driver state score. The backend is Python with FastAPI and processing and endpoints, and the front end is React plus TypeScript plus Tailwind to display the dashboard, charts, and alerts in real time. Snowflake is my data and AI hub. I stream the fatigue metrics into Snowflake so fleets can see trends over time and across routes. And Snowflake Cortex generates plain language summaries and recommendations, like which route segments have a higher fatigue risk and what scheduling changes could reduce it. Building this took iteration. Early on, I had false positives from lighting and camera angle changes, so I repeatedly tuned thresholds and tested again. Adjust, test, review failures, then improve. For validation, I tested across different lighting, distances, and deliberate drowsy behaviors to make sure the metrics move correctly and the alert triggers consistently when risk arises. And for responsible AI, Lucid can store metrics and alerts, not raw face data, and any real deployment would require clear consent and safety policies. Thanks for watching, and this is Lucid.